All right, let's do a bunch of examples of just evaluating inverse trig functions. So let's take, for example, arcsine of 0. What's arcsine of 0? Well, to figure this out, you could draw a little picture, okay? Draw a little picture and think about, all right, where's 0? When is sine going to be equal to 0? Okay, so because for arcsine of 0, that means that sine would be 0, and we're trying to figure out what angle makes that happen. So sine, recall, is the y coordinate, so that would be sine equals 0 would be here at y equals 0. And then we just remember, well, what is the range of values? You know, what is the range for the arcsine function? It's this one, right? It's over here, negative pi over 2 to pi over 2. So, of course, we'd be talking about that point right there, and the angle, which terminates at that point, is 0. So this equals 0. Let's do another one. What is arcsine of 1? Well, again, draw your unit circle. 1 occurs right up here. There's 1, right? 0 last time. There's 1 on the y-axis, and you know, thinking about our range of values being on this side, that point right there is where it's going to happen, and that is when the angle is pi over 2. By the way, angle outputs for inverse trig functions are usually given in radians. You can, if you'd like, talk about those in degrees, but radians is much more common. What about arcsine of something like 2? Arcsine of 2. Well, here's your unit circle. Remember, sine, we'd have to have sine be giving us an output of 2. So you would find 2 on the y-axis, right? Here's our y-axis. 2 is going to be up here. And the question is, what angle in this domain here is going to give us a sine value of 2? And the answer is none. There is none, right? This is undefined. Okay, recall from the previous video, let me pull up that piece of paper. From the previous video, remember that that our sine function only has a range of numbers from -1 to 1. So our arcsine function only has a domain from -1 to 1. So 2 is outside the domain of the arcsine function, therefore undefined. Okay, this is kind of like, for example, kind of like saying, what's the natural log of -5? Undefined. -5 isn't in the domain of the natural logarithm, right? Sort of like that. Let's do one more of these with sine, and then we'll do some cosines and some tangents. So let's do like arcsine of -1/2. So here's your circle. Sine being the y-coordinate, we find -1/2 here on the y-axis, and then we want something in this range of values here. So you trace over, and you find a point right there, and then ask the question, what is that angle right there that gives you the y-coordinate of -1/2? Sorry, -1/2. And the answer, if you just remember the unit circle, if you're familiar enough with the unit circle, you might remember that there's a point down here where the coordinates are square root of 3 over 2, comma, -1/2. And that happens at the angle -pi over 6. Okay, if you remember that from the unit circle, then you know the answer to this is going to be -pi over 6. Okay, so doing these, evaluating these for specific numbers like this, sometimes we can call up our memory of the unit circle, and having memorized a bunch of stuff on the unit circle would allow us to figure out what these are, just like this. Okay, so it's pretty important. I would say it's pretty important for this unit to memorize the common angles on the unit circle and the coordinates of their terminal points. Okay, so if you haven't been working on that, get on that. All right, let's do some with cosine. Let's do arc cosine. What's arc cosine of 0? All right, well, arc cosine of 0, this time cosine is the x coordinates, right? So we'd find 0 on the x-axis, and then the domain that we restricted to, or the range of arc cosine, is this range here, and 0 to pi. So trace up, find the point. That point is at pi over 2, so the answer here is pi over 2. Okay, 6. Let's do arc cosine of the square root of 2 over 2. Square root of 2 over 2. All right, x-axis, square root of 2 over 2. What is square root of 2 over 2 going to be? It's going to be somewhere over here, positive side. Square root of 2 over 2 is approximately there-ish. And if you trace up to to the point, tracing up, not down, right? Because we're always trying to trace over to this range, the top here. That angle right there, that angle there is pi over 4. Okay. Again, knowing the unit circle would remind us that is the case. One more. What is, let's see, what is arc cosine of -1? Well, find -1 on the x-axis right over here, -1, and within our range of values here, that point over there is going to be at when the angle is pi. So arc cosine of -1 equals pi. So there's some examples with cosine. Now let's do some with tangent. Number 8. Let's do arc tangent of 0. I'm always starting with 0 just as a reference. It's just start with something simple. All right, so 0. So now on our circle, we're going to think about drawing a ray with slope 0 as it comes out from the center. So slope 0 is there. There's our ray with slope 0. And now we think about that's an open circle there. We think about the range of values we want. We want something in that range right there. And so right there, clearly, the angle is 0. So that gives us an output of 0. If you did arc tangent of 1, all right, then on your unit circle, you would want to draw a ray with slope 1. There's slope 1, right? Slope 1 is a line of slope 1 comes out from the origin at an angle of 45 degrees, right? Which is, in radian terms, that's pi over 4. And pi over 4 is in our range of arctangent. So this, hang on a second, equals pi over 4. All right. One more. What if you wanted arctangent of like -10? Well, it's going to be harder to do, but -10, if you draw a ray coming out at a slope of -10, you want to draw it down here, something like, maybe sort of like that. And I'm always drawing it coming this direction. I don't draw it going that way. Okay, I don't draw it going sort of like to the left, because because you don't use the left side of the circle for the arctangent range. You only use the right side of the circle. So within this range of values, -pi over 2 to pi over 2, within that range of values, there's going to be some angle down here where the slope of that ray there is -10, and that is going to be sort of close to, I don't know, it equals what? I'm not sure exactly what it is, and we might want to pull out a calculator to evaluate that for us, but it's going to be something close to -pi over 2, okay? Because you got to get pretty far down there before you're going to get a slope of -10. If you made this like -100, you'd have to have a really steep slope, so you're going to get even closer to -pi over 2. Close-ish. All right. Let's see. That'll be it for this video.